Okay, hello everyone. I welcomes to all in our lecture series on Dirac delta function, and we are discussing these topics which are most essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. Now, last class we have been discussed eighth property of the Dirac delta function in detail. We proved the eighth property. In today's class, we are going to discuss the numerical based upon seventh and eighth property. Okay, so let us start. These things in our previous classes we have been discussed. Yes, this one. Eighth property in detail we have been discussed in our last class. Okay, and we proved this one. I told that this is the general form of seventh and eighth property, where xi is the roots of the function fx. You just remember, most important, which is essential for doing the numericals based upon seventh and eighth property. Now we are going to go for numerical based upon seventh and eighth property. First question, we have to prove that delta x root x minus root a equal to 2 root a delta x minus a. Okay, this much we have to prove. So now we are going to apply the seventh and eighth property, or general expression of seventh and eighth property. What we know, delta fx is equal to summation over I 1 by f dash xi delta x minus I. This much we know. Here fx, if I am going to compare this one with this one, fx is your root x minus root a, and the roots from this equation, the roots will be only one root. We can get x equal to a, and f dash x we can find 1 by 2 root x, right. Now we are going to write the value. So delta x minus root a will be equal to 1 by derivative of the function substituted by its roots. So first root, or only one root is there, only a. So if I am going to substitute a over here, it will be 1 by 2 root a mod delta x minus a. There are no other roots, only one root, so only one term here we can get. So that implies this value will be equal to, here you can see, this 2 into root a will be moved to the numerator, and we can find this one, hence proved. This is very much important, you just practice it. Okay, now we are going to go for the second question. Given that 0 to 2 pi cos x delta root x minus root pi into dx. So here, just before, in our question number 1, what we proved, this value equal to this one. So this result we are going to apply directly over here. From the previous question, what we know that this delta root over x minus root over of a equal to 2 root over of a delta x minus a. Therefore, instead of a, here in the question root over of pi is there, here root over of a was there, so root over pi. So delta root over x minus root over pi will be 2 into root pi into delta x minus pi, right. Now we are going to substitute this one over here. That implies 0 to 2 pi cos x. This integral will be equal to, here delta x root over of x minus root over of pi is nothing but this one. So this value is a constant taken outside of this integration. 0 to 2 pi cos x is there, and delta x minus pi dx, right. Now we are going to use the fourth property, this one, f of a. So here a is your pi, and you just check always this limit, in this limit this a is exist or not. So the limits or the range is your 0, this is your pi, this is your 2 pi. Suppose in this range we are integrating, and the delta function exists at pi, so we can get the value. So just apply the fourth property. So this will be f of a, that means 2 root pi is there. Now we have to just substitute, instead of x it will be pi. So here a is your pi, so cos pi is your minus 1, so answer will be minus 2 root over pi. This is very important question. Okay, now we are going to go for our next question, this one. Find the value of cos x delta x square minus pi square dx. So here we are going to use the general form of 7th and 8th property, that is your delta fx is your 1 by f dash xi summation over delta x minus xi. So here fx, if I am going to compare with this one, is your x square minus pi square. The roots will be x equal to plus or minus pi, and the first derivative of fx is your 2x. So that implies this integral will be equal to here this value we have to substitute this one. So cos x is there, cos x I written over here. So here two roots, so two terms we can get 1 by 2 pi mod here 2 pi, because here 2x we found. F dash first root, f dash x second root. F dash x first root means pi, 1 by 2 pi mod delta x minus pi plus 1 by the second root means minus pi, so it will be minus 2 pi. So minus 2 pi mod delta x plus pi. So if I put over here minus pi, so obviously it will be plus pi dx, right? Right. Now here we can get the two integrals. This integral, another integral is this one multiplied with cos x. Just apply the fourth property. If I am going to apply the fourth property, this will be cos pi and this will be cos minus pi, and this mod value 1 by 2 pi mod 1 by minus 2 pi mod always positive 1 by 2 pi, and first integral, considering first integral and applying the fourth property, it will be cos pi, and for this case it will be cos minus pi, right? Cos pi is your minus 1, as your cos x is your even function, cos minus pi is your itself cos pi, itself it value is minus 1, so the answer we can get minus 1 by pi. Okay, now we are going to go for another question, that find delta sin x is most important, very important. Okay, very important. In general, what we know from 7th and 8th property, we know delta fx equal to this much. Okay, so here xi is the roots. Just compare these functions. Here fx is your sin x and first derivative will be cos x. Now the roots of the sine is your what? Sin x. If sin x equal to 0, that means x equal to plus or minus n pi. So these are the roots up to plus or minus infinite. Okay, sin x has these are the roots. Now delta sin x, in general what we can write, the summation will be start from minus infinity to plus infinity, each term 1 by your cos the roots in general plus or minus n pi delta x minus the roots plus or minus n pi, right? Right. That implies delta sin x will be, here you can see, first I am going to consider the minus values, then I am going to consider the plus values. So here minus values are there, so it is difficult to represent all the values, that means from minus infinite to 0, then 0 to infinite. Some of the terms I have been represented over here. You just consider this term for minus 3 pi, right? So here cos minus 3 pi, delta minus of minus 3 pi cos, sorry, delta x plus 3 pi. So before that, what is the term you are going to consider? Cos minus 4 pi delta x plus 4 pi, like that. Okay, I not written, you just imagine. So these are the term are there, plus 1 by cos minus 2 pi delta x plus 2 pi uh, plus 1 by cos minus pi delta x plus pi. Then after that, which term will come? 0 term. Okay, because n also 0 is the root of the sin x, so 1 by cos 0 delta x plus 0, right? Then after plus, here up to this we consider the minus terms or minus roots, after that plus roots. So plus roots means 1 by cos pi delta x minus pi, then after 1 by cos 2 pi delta x minus 2 pi, 1 by cos, this is your 3 pi, mistakenly written, I will correct it, 3 pi delta x minus 3 pi. Okay, and so on. Okay, consider this term first. This term value cos of 0 is value is 1, only we can get delta x, here I written. Okay, now you can just consider this one, cos 3 pi, cos any pi either plus 1 and minus 1, mod value will be 1. So this 1 by cos 3 pi value, 1 by cos 2 pi value, 1 by cos minus pi mod So these values are 1. So only we have to write these terms. Okay, delta x plus 3 pi, then delta x plus 2 pi, delta x plus pi, delta x, then delta x minus pi, delta x minus 3 pi, delta 2 pi, delta x minus 3 pi, and so on. You just remember this one. This expression is required for doing some numericals. Okay, just remember. And here this will be 3 pi. I'll correct it, no problem, at the time of uploading this note. Okay, now we are going to go for another numerical. Here you can see here delta x sin x is represented by this one. Now using this one we are going to solve this integral. Find the value of minus pi by 2 to plus pi by 2 plus 5 pi by 2 cos x delta sin x dx. Most important question, most important question. Okay, previously what we found, delta sin x equal to this much. Okay, so as per the limits given in the integral minus pi by 2 to plus 5 pi by 2, in between the limits what are the roots are possible? Only these three roots are to be possible. Here 5 pi by 2, that means here 2.5 pi, that means up to 2 pi, and here minus pi by 2, minus pi by 2 is there, means 0. So 0 to 2 pi, 0 to 2 pi positive. Only these three values are possible as per the limits given in the question. Right. Now here delta sin x is these things, this much series you can say, but as per the question only we have to consider these three: delta x minus pi, delta x minus 2 pi only. So for this case, as the roots are 0, pi, 2 pi, delta sin x will be this much. Got it? Got it. Okay, now we have to just put these values over here. That implies minus pi by 2 plus 5 pi by 2 cos x delta sin x dx will be this much cos x, and this much same thing I have written over here. Here these are the three terms, 1 2 3. So obviously three integrals we can write over here. Minus pi by 2 to plus 5 pi by 2 cos x delta x dx. Here cos x delta x minus pi. Here cos x delta x minus 2 pi. Here delta x is there, or x minus 0 you can say. So this integration value by using fourth property, how much we can get? Here cos 0 value, cos 0 f of a, that means delta. Okay, you just consider the fourth property. This is the fx, so f of 0 means cos 0. Here f of a means pi, cos pi. Here f of a means cos 2 pi. Cos 0 value is your 1, cos pi value is your minus 1, cos 2 pi value is your 1. So answer will be 1. This is the most important question for your exam point of view. Okay. Now we are going to go for our next question. This one. This question some year asked in the jest. Find the value of minus infinity to plus infinity e to the power minus x mod by pi delta sin x dx. Okay. Uh, here as per the limit, all the sine roots we are going to consider. And in general, see, first we are going to consider what is the value of delta sin x. Already we have been evaluated, and here also again I written that delta fx is your this one. Xi is the representation of the root. From the previous question we found that delta sin x equal to 1 by cos n pi plus or minus n pi, delta x minus plus or minus n pi. These things we have been discussed, and we found this one. Okay, delta sin x equal to this one in general. For this case, the limits are minus infinity to plus infinity. That means all the roots are to be considered. That means 0 plus or minus 2 pi plus or minus pi plus or minus 2 pi 3 pi 4 pi up to plus or minus infinite values we are going to consider. So that implies this integration value minus infinity to plus infinity e to the minus x mod by pi delta sin x dx will be equal to, here you can see, minus infinity plus infinity. This function as such I have been written over here. Delta sin x value just I written over here. Bracket starts, bracket ends over here, and all the values I have written. Dot delta x plus 3 pi, x plus 2 pi, x plus pi, delta x minus pi, delta x minus 2 pi, delta x minus 3 pi, and so on. Right. So likewise, from this we can get the infinite number of terms. That means this will be multiplied with this term, one integral, this will be multiplied this one, another integral, like that, like that. So the integrals are dot 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 dot, means these integrals we are not written, these integrals are there, we are writing few integrals only here, minus infinite to plus infinite e to the minus mod x by pi into this value. Okay, then this term with this one multiplied and written over here, then this term multiplied with delta x plus a, then multiplied with delta x, multiplied with delta x minus a, delta x minus pi, x minus 2 pi, x minus 3 pi, and so on. Got it? Okay. Now same thing I have written the term whatever over here, same thing. Now you just carefully watch, consider this one and apply the fourth property. That means f of a, what is the fx value over here, here this one, f of a value is your minus 3 pi, right? Minus 3 pi. So if I'm going to apply the fourth property, this will be e to the minus 3 pi mod, right? Got it? The fx by pi. That means this is your fx value, this is your fx. By fourth property, f of a is your nothing but minus 3 pi, so e to the power minus of minus 3 pi by pi. Same thing over I written over here, I haven't written over here. If I will consider this integral and applying the fourth property, we can get this one. Likewise, from this integration we can get this one. Okay, here e to the power minus of minus 2 pi mod by pi. Okay, and from this term we can get this one, and from this term we can get e to the power minus pi mod by pi, then we can get e to the minus 2 pi mod by pi, this one, and so on. Okay, here you can see pi got cancelled, mod value negative is positive, so this from this we can get e to the minus 3, then e to the minus 2, e to the minus 1, this will be e to the 0. From this we can get e to the minus 1, e to the minus 2, from this e to the minus 3, and so on. Okay, so here e to the power 0 value is 1, this value I have been written over here. Okay, now here you can see e to the minus 1, again e to the minus 1 repeated, e to the minus 2, e to the minus 2, e to the minus 3, e to the minus 3 repeated two times. So we can write 2 into e to the minus 1, e to the minus 2, e to the minus 3, and so on. E to the 0 value 1 I have been written over here. Now 1 plus 2 into e to the power minus 1 taken common from all the terms, then we can get 1 plus e to the minus 1, e to the minus 2, and so on. This is a infinite series, okay, and whose values will be a by 1 minus r, that we know. For this type of infinite series, the value will be a by 1 minus r, right? So is equal to 1, this value is your 1, double equal sign is given, no need, 1 plus 2 into e to the minus 1 into here 1 is the matlab means first term, the first term is your 1, and the ratio between the two terms, is your e to the minus 1. Here e to the minus 1 by 1, e to the minus 1, e to the minus 1, e to the minus 2 by e to the minus 1, the ratio between the two terms is your e to the minus 1. So r is nothing but e to the minus 1, and you just solve this one, you can get e plus 1 by e minus 1 is the answer of this question. Okay, this is one of the important question asked somewhere just. Next question you just do by yourself, the answer will be this much. Similar method you have to use, find the value of 0 to plus infinity e to the power minus x delta sin x. Okay, here you can see I'm going to give you somewhat hints. Delta sin x values are from minus infinite to plus infinite terms, but as per the limit it is given 0 to infinite. 0 to infinite means these terms are not to be considered, only from here x minus 0, x minus 0 to up to plus infinite you are going to consider. Okay, and you can found this type of series, and the answer will be this much, right. Now we are going to go for another question, very simple question. Minus infinity to plus infinity x to the power 5 delta x square minus x minus 2 dx. So here this is your fx value, right? By considering the general form of 8th and 7th and 8th property, delta fx is equal to this much, and xi represent the roots. Here we found fx value is this one, and f dash x will be how much? 2x minus 1. Now we are going to find out the roots. As the power maximum highest power is 2, obviously we are going to get the two roots. You just find out x square minus 2x minus 2 equal to 0. Just solve. You can find the two roots are 2 and minus 1. Now we are going to consider this one. Now we have to substitute. Okay, so the two roots means two terms are there. We can find the two terms. So delta x square minus x minus 2 can be written as 1 by f dash 2 for first root, delta x minus 2. For the second root, it will be 1 by f dash minus 1 delta x minus of minus 1 or x plus 1, right. 1 by, here f dash value is your 2x minus 1. So if I'm going to put x equal to 2 over here, it will be 4 minus 1 is your 3. So 3 mod delta x minus 2 plus 1 by, here the root is your minus 1. If I'm going to put minus 1 over here, so 2 into minus 1 minus 2 minus 1 minus 3 mod delta x plus 1. Now this integral will be written as minus infinity to plus infinity x to the power 5. Instead of this one, we have to write these two terms, right. So now we are going to consider these two integrals. First integral is your 1 by 3 mod, nothing but 1 by 3 integration from here. You can see 1 by 3 mod 1 by minus 3 also, both are same. It will 1 by 3 taken outside of these integrations, minus infinity to plus infinity x to the power 5 delta x minus 2 here dx, and another integration will be x to the power 5 delta x plus 1 dx. Now just apply the fourth property, this one, fx delta x minus a equal to fa. So here a is your 2. So the answer of this one, this integral will be how much? 1 by 3 is there. 1 by 3 is there. So the answer of this integral will be here 2 to the power 5. 2 to the power 5. For this one, a is your minus 1, right? So this will be minus 1 to the power 5. The answer will be 31 by 3. Okay. Yes. Finally, I given three questions, similar type of questions, whatever we have been discussed, I given to you. You just do by yourself. Okay. So here I am going to stop uh, this discussion. In our next class, we are going to discuss ninth property of the Dirac delta function and corresponding numerical. Thank you so much for watching this video. Thank you.